Welcome to the DX Today podcast, your daily deep dive into the AI ecosystem. I'm Chris, and joining me as always is Laura.
Thanks, Chris. And I have to say, I am genuinely excited about today's topic because for once, we get to talk about something that changes how the models actually generate text, not just what they can do.
That is exactly the hook that pulled me in this week. Google DeepMind just dropped something called DiffusionGemma, and the headline claim is that it writes text up to 4 times faster than a normal model.
Right, and the word that matters in that sentence is diffusion, because for the last 3 years, almost every large language model you have ever touched works in a completely different and much slower way under the hood.
Let's set the stage for people who do not live inside model architecture papers all day. When you ask ChatGPT or Gemini a question, how is it actually building the answer word by word?
So the standard approach is called autoregressive generation, and the simplest way to picture it is a model that writes one token at a time, left to right, where every new word depends on every word that came before it.
So it is essentially predicting the next word, then the next, then the next, in a strict sequence, which means you cannot really produce word 50 until you have already committed to words 1 through 49.
Exactly. And that sequential dependency is the bottleneck. Even with all the parallel hardware in a data center, the model is fundamentally stuck waiting on its own previous output before it can take the next step forward.
Okay, so that is the world we have been living in. Now explain what diffusion does differently, because I know this idea originally came from the image generation side of the field, not from text at all.
That is the beautiful part. Diffusion is the technique behind image generators like Imagen and Stable Diffusion, where the model starts with pure random noise and then iteratively refines that noise step by step until a clean picture emerges.
So instead of painting the image 1 pixel at a time in a fixed order, it sort of sharpens the whole canvas at once, refining everything in parallel across multiple passes until the details lock into place.
Precisely. And Diffusion, Gemma takes that same parallel, refine the whole thing at once philosophy, and applies it to language, generating entire blocks of text simultaneously rather than dragging itself along one single token after another.
That is a genuinely wild mental shift. So rather than a writer typing left to right, it is more like a sculptor starting with a rough block and chiseling the entire passage into shape over several iterations.
The sculptor analogy is perfect, and the technical term Google uses is discrete text diffusion. It starts with a noisy, masked version of the output and progressively denoises it until coherent, readable text appears across the whole block.
And I have to assume this is why the speed number is so striking. Because if you are refining many tokens at once instead of waiting on a strict sequence, you escape that one word at a time bottleneck entirely.
That is the whole pitch, and on GPUs, Google is reporting up to 4 times faster generation compared to the standard autoregressive Gemma 4, which in inference cost terms is an enormous and very real difference.
Let's put some numbers around the actual model, because I think people hear Google and assume some gigantic 500 billion parameter beast that nobody outside a hyperscaler could ever realistically run on their own hardware.
That is the other surprise here. Diffusion. Gemma is a mixture of experts model with 26 billion total parameters, but it only activates roughly 3.8 billion of those parameters during any single inference step.
Break that down for me, because mixture of experts is one of those phrases that gets thrown around constantly, but I think most listeners have never had it explained in plain everyday language.
Think of it like a hospital with many specialist doctors on staff. You do not wake up every doctor for every patient. A routing system sends each case to the few specialists who are actually relevant.
So the model holds 26 billion parameters worth of knowledge in total. But for any given request, it only fires up the small handful of experts it needs, which keeps the compute costs surprisingly low.
Exactly, and the practical payoff is jaw-dropping. When you quantize the model down to NVIDIA's NVEP4 format, the whole thing fits inside roughly 18 gigabytes of video memory, which is a high-end consumer graphics card.
Wait, so we are talking about a frontier lab diffusion language model that a serious hobbyist or a small startup could actually run on a single beefy desktop GPU, not a rack of data center accelerators?
That is genuinely the situation, and it gets better because Google released the weights under an Apache 2.0 license on Hugging Face, Kaggle, and the Vertex AI Model Garden, so anyone can download and build on it.
The open license is a big deal, and I do not want it to get lost in the speed conversation, because Apache 2.0 is about as permissive as it gets for commercial use and modification.
It really is, and that choice signals something about strategy. Google is not treating this as a locked-up crown jewel. They are handing the diffusion technique to the entire developer community to experiment, fine-tune, and push forward.
Now I want to be the skeptic for a moment, because whenever a number like 4 times faster shows up, my immediate question is always the same. What did they have to give up to get that speed?
That is the right instinct, and Google is refreshingly honest about it. On established benchmarks like MMLU and the standard coding evaluations, DiffusionGemma actually scores lower than the regular autoregressive Gemma 4 model does.
So this is not a free lunch. You are trading some raw answer quality and reasoning accuracy for a very large gain in generation speed, which is a classic engineering trade-off rather than a pure breakthrough.
Right, and to their credit, Google is explicitly calling this an experimental release. They are openly recommending that if your production use case prioritizes output quality, you should still reach for the standard Gemma 4 model instead.
I actually find that framing reassuring rather than disappointing, because it means they are publishing a research direction in the open instead of overselling a half-baked product as the next great leap forward.
And there is one quirky detail I absolutely love. A fine-tuned variant of DiffusionGemma reportedly excels at structured reasoning puzzles like Sudoku, which actually tells you something deep about why diffusion can be powerful here.
Now that is fascinating, and I think I see where you are going, because a Sudoku grid is not really a left-to-right problem. You have to satisfy constraints across the entire board at the same time.
Exactly. That is the insight. A left-to-right model commits to early choices before it can see the whole picture, but a diffusion model refines the entire grid in parallel, so it can reconcile global constraints far more naturally.
So the architecture is not just faster. It might genuinely be better suited to certain classes of problems, where the answer has to be globally consistent rather than built up one local decision at a time.
That is the tantalizing possibility, and it suggests diffusion text models are not merely a speed hack. They could be the right tool for planning, structured generation, and tasks where you revise a whole draft holistically.
Let's zoom out to the economics, because I think the speed story is really an inference cost story in disguise. An inference cost is the thing quietly eating every AI company's margins right now.
You are absolutely right to connect those dots. Training a model is a one-time enormous expense, but inference is the recurring bill that scales with every single user query, and it never stops growing as adoption rises.
So if a diffusion approach can cut generation time by something approaching 4 times, you are not just making things feel snappier, you are potentially slashing the cost of serving millions or billions of requests every day.
And that matters enormously for the agent era we keep talking about on the show, because autonomous agents make dozens or even hundreds of model calls per task. So latency and cost compound very quickly at scale.
That is a great point. An agent that has to think, act, observe, and replan across many steps lives and dies by per-step latency. So shaving that down could be the difference between a usable agent and a sluggish one.
Exactly. And that is why I think the real significance of DiffusionGemma is not the model itself, but the proof of concept. It shows diffusion can work for text in an open, reproducible, downloadable form.
Let me push on the bidirectional attention detail you mentioned earlier, because I think that is the secret ingredient that actually makes the parallel generation possible in the first place, and it deserves a clear explanation.
Happy to. A standard autoregressive model uses causal masking, which means each token is only allowed to look at the tokens before it, never after, precisely because it has not generated those future tokens yet.
Whereas a diffusion model, since it is refining a whole block at once, can let every token look both backward and forward across the entire passage, which is what bidirectional attention actually means in practice.
Right, and that two-way visibility is enormously powerful because the model can keep the beginning of a sentence consistent with the end and revise earlier word choices once it sees how the whole thought is shaping up.
So in a strange way, this is closer to how a human writer actually drafts, where we write something, glance back, see the ending, and then go fix an earlier sentence so the whole paragraph hangs together.
That is a lovely way to put it, and I think it captures why so many researchers are excited. Autoregressive models can never truly revise, while diffusion models have iterative refinement baked into their very core.
Before we get to the competitive picture, I want to ask the practical question our developer listeners are surely thinking, which is, what does someone actually do with this model today, now that the weights are freely downloadable?
Great question, and I would frame it as 3 buckets. First, anything latency sensitive, like autocomplete, live chat, or real-time coding suggestions, where shaving milliseconds off every response genuinely changes how the product feels to use.
That makes sense, because in those interactive cases, a user can literally feel the difference between a model that streams instantly and one that pauses, and speed there is almost a feature in its own right.
Exactly. And the second bucket is structured generation, the Sudoku-style tasks we mentioned, where global consistency matters and the parallel refinement actually plays to the architecture's strengths rather than fighting against them the whole time.
And I imagine the third bucket is pure research, where people will take these open weights apart, study how the diffusion process behaves, and try to figure out exactly where the quality gap with autoregressive models comes from.
That is the third bucket precisely, and it is arguably the most important one, because the fastest way to improve a new technique is to put it in thousands of curious hands and let the community probe its limits.
One thing I am curious about is whether the training process itself is fundamentally different. Because if diffusion text models are harder or more expensive to train, that could limit how quickly other labs can chase this direction.
It is a meaningfully different training objective, since instead of simply predicting the next token, the model learns to denoise corrupted text across many noise levels, which is a richer but also more complex signal to learn from.
So the cost and difficulty of training is part of the trade-off too, which makes Google handing over working open weights even more valuable, because most teams could never afford to discover this recipe entirely on their own.
I think that is exactly right, and the fact that Google open-sourced it under Apache 2.0 almost guarantees it. Because now every researcher and startup can pressure test the approach, find the weak spots, and try to close that benchmark gap.
And if somebody does manage to close that quality gap while keeping the 4 times speed advantage, that is the moment this stops being an interesting experiment and starts genuinely reshaping how the whole industry builds and serves models.
That is the bet, and honestly, that is why I love covering releases like this one, because it is a reminder that the fundamental architecture of these systems is still very much an open and contested research question.
It really is, and I think the takeaway for our listeners is to watch the diffusion versus autoregressive race closely, because the winner of that quiet technical contest could shape the cost and speed of AI for years.
Beautifully said, and my one-sentence summary would be this. DiffusionGemma is not the fastest model that will ever beat the benchmarks, but it might be the spark that proves a faster paradigm is genuinely viable.
That is the perfect place to land it. A speed-first, open-weight experiment that trades a little quality today for a potentially enormous shift in how every model generates text tomorrow. And we will absolutely be tracking it. That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.